Okay, this is going to be the Algebra 2, Chapter 1 on transformations for the 2014-2015 school year. I've made some updates in the strategy and what you'll have to be able to do. So I suggest you watch this along with your review packet. What I'd like to do is go over first how we get key points on the parent functions. And I want to do that over here, and then I'm going to erase it. But if you've got a quadratic, okay, if you've got a quadratic, all right, what we want to do for key points, all right, we're going to do 1, 2, -1, and this is, wait, hold on, I need to do something a little more space. I'm going to do it right here. So if you've got a quadratic, okay, what you're going to want to use is 1, 2, -1, and -2. Now, to get those y values, okay, that's nothing but just squaring. If you go back to your menu, that's nothing but just squaring the numbers. 1 squared, 2 squared, -1 squared, and -2 squared. Okay? All right, so that's how you get those numbers of 1, 4, 1, and 4. And go ahead and just make sure you have those written down, okay? All right, 1, 4, 1, 1, 2, 4, -1, 1, -2, 4. Okay, so that's for the quadratic, all right? Now, if you use absolute value, if you got the absolute value function, okay, we're 1, 2, -1, -2, okay? All right, once again, if you need to do that, figure those out, option. I'm going to do F6 to go over, num, ABS, ABS1, ABS2, ABS3, all right, oh, whoops, I'm sorry, not ABS3. ABS -1, all right, ABS -2, okay? So if you do these, you got 1, 2, 1, 2, okay? So that's if you have absolute value, okay? Now, for the square root function, okay? If you've got the square root function, if we use these same ones, okay? All right, if I do square root of 1, it's 1. But when I do the square root of 2, nasty. Square root of 3, nasty. Square root of 4, okay, now I've got, because I want to graph 2 points to the left and 2 points to the right, so I'm not going to use 1, 2, I'm going to use 1, 4, okay? And I got the results of 1 and 2 there. Now, if I do the square root of a negative number, gives me that. It's error, so I can't use the negative. So all I can use for that, for square root, is that. So throughout this review, I'm just going to reference those numbers. That's how you get them, all right, just to speed up the process, okay? All right, so I'll leave that for that problem. This one, all right, so what we have to graph first is the anchor point, okay? The anchor point would be on the inside. Now, here's an example on the inside. This one, -3, is on the outside, okay? So that's going to be 0, -3. So we follow here. We go opposite for anything inside. So 0, -3. 0 over, -3 down, okay? Then I'm going to use my key points. Since it's a quadratic, all right, so x squared, all right, which is the y that we're using. Okay, 1, 2, -1, -2. Okay, now what this means for me is I go right 1, up 1, right 2, 1, 2, 1, 2, 1, 2, 3, 4, left 1, up 1, left 2, up 4. Okay, and this is a U shape. Okay, they should be U's for quadratic. It should be a U. Okay, square root function. Here are the amounts I'm going to use. Okay, now my anchor point. This is on the inside, so that's going to be 1. Okay, nothing on the outside, so 0. There's my anchor. All right. Now, since I have this 3 here, I'm going to multiply these by 3, so it's going to be 3 and 6. So I'm graphing 1 right, 3 up. 1 right, 1, 2, 3 up. 4 right, 1, 2, 3, 4. 1, 2, 3, 4, 5, and 6. So this is the square root. Looks like a little arrow. Don't extend it past this. It starts there and goes up. Okay? Let's go down to these. Okay? Absolute value. So what I'm going to have there for absolute value is 1, 2, -1, -2, so 1, 2, 1, 2. That's where I'm going to start from. Okay, now, since my anchor point, everything is inside, inside is going to be -1, okay, because it's opposite. Outside is 0, so here's where I'm at, boom, right there. Now, since this is 1/5, what I'm going to do is I'm going to multiply all these by 1/5. Okay, so that's going to be 1/5, that's going to be 2/5, 1/5, 2/5, okay? All right, use your calculator if you need to. All right, so 1 over, okay, 1/5 up, okay, 2 over, 2/5 up. 1 left, 1/5, 2 lefts, 2/5. So it's a very flat V, okay? The absolute value is always a V, okay? This one, all right, 1, 2, -1, -2, 1, 2, 1, 2. Okay, my anchor point there is -4, -7. Opposite on the inside, follow on the out. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and 7. Okay, so 1 right, 1 up, 2 right, 2 up. 1 left, 1 up, 2 left, 2 up. So this is left and right, up and down. V. Okay? All right, next page. Okay, anchor point for this one. Nothing's on the inside. That -4 is considered the outside. Okay? All right? So, what I want to do here, all right, this is going to be 1, 4, 1, and 2. Now, since that's a negative, I'm going to multiply this by -1. So I got -1, -2. Okay? So 0, 1, 2, 3, 4 down. Okay? 1 right, the negative means go down. So 1 right, 1 down. 4 right, 1, 2, 3, 4, 2 down. Okay? This one, all right, my anchor point there is going to be -4, 0, because that's on the inside. That 2 is not going to affect that anchor point. So -4, 0 is here. My normal points for this, okay, the 2 is going to get multiplied by all these. So I got 2, I got 8, I got 2, I got 8. So 1 right, 2 up, 1 right, 2 up, 2 right, 8 up. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay? 1 left, 2 up, 2 left, 8 up. Okay? And that's that. All right? Now, for a problem like this, what you should do, okay, I think it's the same picture. Okay, so what we can do, let's go ahead and write down the x and y's for each of these. Okay, that's going to be 1, 2, 3, 1, 2, 3, 4, 5. So that's -3, -5. That's -2, 0. That's -1, 2. That's 0, 0. That's 1, -2. That's 2, 0. And that's 1, 2, 3, 1, 2, 3, 4, 5, 3, 5. Okay, now, for this problem, okay, what would happen is, because that 1/2 is there, all of those y's would get multiplied by 1/2. So what I'm going to be left with is x is going to stay the same, nothing's going to happen to that, but if I multiply times those y's, that's going to be negative, basically it's going to be -2.5. All right, still going to be 0 because 1.5 times that. -1 times 2 would be 1. 0 times 0 would be 0. 1 times, or 1/2 times that would be -1. 2 and 0, 3 and 2.5. So what you do is you go ahead and graph it. So -3, 0, -3, 1, 2, and 3, down 2.5. 1, 2, 2.5. Okay, let me use a different color. All right. 2.5 would be about here. -2, 0, same thing. -1, 1 would be there. 0, 0 would be there. 1, -1 would be here. 2, 0 would still be there. And 3, 2.5 would be here. So it's a little bit narrow or a little bit skinnier, all right, deal there, okay? For this one, since this is on the outside, we're going to subtract 5 from the y's. Okay, so here we multiply. Subtract 5 from the y's. So what I would have is -3, -10, -2, -5, -1, -3, 0, -5, 1, 1, -7, and 2, -5, and 3, 0. Okay, so I just go ahead and I graph those points. -3, 10 would be 1, 2, 3, 4, 5, 6, 7, 8. Let's do 9 and 10. -2, -5. So -2, 1, 2, 3, 4, and 5. Okay, -1, -3, 1, 2, and 3. 0 and negative 5, 1, 2, 3, 4, and 5. Okay, 1 and negative 7. All right, probably down about here. 2 and negative 5 would be about here. And 3 and 0 would be about here. So here's what my graph looks like. It goes like this, okay? All I did was shift it down. Okay, identify these. This is a line, square root, absolute value, quadratic. Okay, pretty simple. All right, write the equation. Now, what you should do, this is an absolute value. So I know when I make my equation, there's going to be an absolute value symbol there. Okay? All right, I'm going to spread this out a little bit. Put the x there. All right, now, my anchor points, the next thing you should find is 0, negative 2. Now, that would go for x, so nothing's going to change. Negative 2 is going to be on the outside there. Now, what I have to figure out, normally my points are 1, 1, 2, 2, negative 1, negative 2. I'm sorry, negative 1, 1, negative 2, 2. Now, what I got to look at is, all right, I'm going 1 right again. 1 right, but now to get there I go 1, 2 up. That's how much I have to go to that. Okay? Now if I go 2 to the right, that's 1, 2, then I go 1, 2, 3, 4. So I look at how did this change? And all the time that's going to be a multiplication factor. All right, how did both of those change? The only way that would happen is if it was multiplied by 2, so that's where I put there. Okay? Now, this one here, this is a square root function. Right? Now, put the x there. That's negative 1, negative 2, negative 3, negative 4. So I'm negative 4, 0. Since that's negative 4, 0, I'm going to put plus 4. Nothing on the outside. Normally my points are 1, 1, 4, 2. So 1 right, 1 up. 4 right, 1, 2, 3, 4, 1, 2. So what multiplication factor? A math multiplication factor of 1. Okay? All right, state the zeros, the x-intercepts, the y-intercepts. Okay? Now, the zeros and the x-intercepts, this is the same conceptually. Okay? That's it. The zeros, though, you're going to write like equals. X equals negative 1, x equals 3. As the intercepts, though, they're going to have that involved with them. Okay? For the y-intercept, okay? For the y-intercept, that's where it crosses the y-axis, which is going to be at 0, negative 2. Okay? It's going to be at 0, negative 2. All right? So on this one, okay, I actually have to graph this physically myself. Okay? My anchor point is going to be negative 2, negative 1. So that's negative 2, negative 1. I'm normally using these values. Okay, 1, 4, 1, 4. So 1 right, 1 up. 2 right, 1, 2, 1, 2, 3, 4 up. 1 right, 1 up. 2 right, 4 up. Okay, here are the zeros. They cross here and here, so about 1 and 3. X equals negative 1, x equals negative 3. Okay, from an intercept standpoint, that's negative 1, 0, and negative 3, 0. Hopefully you can see that. And the y-intercept is 0, 3. Okay, so I write it like that. Okay. Write the intervals where it's increasing and decreasing. Now, what I would do for this, go ahead and label this point right here. That's the anchor point is 1, 1, 2, 3, and 4. So 1, negative 4. Label your arrows. Since that's a left arrow, that's negative infinity. And since it's going up, it's positive. This is a right arrow. And since it's going up, it's also positive infinity. Now, for these, we only care about the x's. Okay? So, to get the increasing, decreasing, this is decreasing from negative infinity to 1. That's all I care about. And then it's going up from 1 to infinity. So, trace it. Decrease, increase. Okay? And behaviors, as x approaches infinity. All right? So, they're saying, what's happening there? And what you do is you look and say, okay, that's going to be infinity. X approaches negative infinity. Okay, what's happening there? It's also positive. Okay? This one you're going to have to graph yourself. My anchor point there is 1, 2, 3, 4, and 5. Okay? All right? Once again, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Okay, since I got that negative there, I'm going to multiply everything by negative 1. So negative 1, negative 4, negative 1, negative 4. So 1 right, 1 down, 2 right, 4 down. Same thing on the other side. 1 left, 1 down. Okay. All right. Once again, I'm going to label this. This is negative 5. This is 5, 0. Okay. That's 5, 0. That's going to be negative infinity, positive infinity. This is going to be positive infinity, negative infinity. The reason why both, I'm sorry, that should be negative as well. The reason why both of these are negatives is because they're both going down. Okay. So negative infinity to 5, that's going to be my increase. 5 to infinity will be the decrease. Okay? As x approaches infinity, that's going to be negative. As x approaches negative infinity, that's also going to be negative. Okay. All right. Domain and range. Okay? Not much left here. Handful of problems. Okay? Domain and range. All right? I'm going to go ahead and label that point. That's negative 2, 0. This is like an arrow. So that's a right arrow, and it's going up. Now, good rule of thumb. For domain, you're looking for small, okay, small, and big for each one. Now, if both of those answers are, let's say, negative infinity to positive infinity, what you can write is you can write all real numbers. That makes it a lot easier, okay? If it's not one of those, you have to look at the graph. So the smallest x here is negative 2, biggest x is infinity. So because it's a number, I'm going to look here and say, okay, what's the graph doing? Since it's going to the right, okay, all right, so all real number, x such that x, all right, is greater than or equal to negative 2 because it goes to the right. If it would have gone to the left, it would have been negative infinity. Now, all right, let's look at the range, which is the y. Smallest y is 0, biggest is that. So I got to look at this. What happens? It goes up, so that's going to be y is greater than or equal to, and that y coordinate is 0. Okay? Coming over to this, all right, I know this is sort of hard to see. All right, from what I can tell, that's like 1, 2, 3, and 4. Let's call that 4. Let's call that 4, negative 3. As far as the vertex goes, that would be positive and positive. This would be this is like an arrow too, negative and positive. So for the domain, smallest x I see is negative infinity, biggest is that. Since that's the case, it's going to be all real numbers. Okay. Now for the range, smallest is negative 3, biggest is infinity. So I got to look at this. Okay. Since it goes above, that's going to be y is greater than or equal to negative 3 because it goes above. Okay, if it would have gone below, it would have been less than. Okay? All right, once again, you're going to graph this. Okay, for time's sake, I'm just going to graph this for you. That's going to be negative 3. It's going to end up being 1 right, 1 up, 2 right, 4 up. Okay, it's going to look like that. Once again, you could go through the chart if you want. We've graphed a bunch of these. Here's what it would look like. Okay, that's going to be negative, positive. That's going to be positive, positive. Okay? All right, smallest x is that, biggest x is that, so that's going to be an all real numbers type deal. Okay? The smallest y here, that's 0, negative 3. So the smallest y is negative 3, so I got to look at this. Okay? It goes above, so it's going to be y is greater than or equal to negative 3. Okay? This one, I go left 4, 1, 2, 3, 4, down 3. Okay? And the graph is going to end up looking like this. Okay? All right, this is going to be negative infinity, negative, because it goes down. It's going to be positive and negative. All right? Smallest x is this, biggest x is this, so that's going to be all real numbers. Okay? The smallest y is negative infinity, biggest y is negative 3. Now, if I look at this, what happens is this is below. So this is going to be y is less than or equal to negative 3. Okay? All right? Circle all the functions, okay, that have a y of range of greater than negative 2. Okay, so if I graph that, that's 0, negative 2. And since it's positive, it'll go like that. Okay, so that's above at y equals -2, so that's going to be one of them. This would be here, okay, which that point would be -2, 0. So that obviously can't be that. That's not going to be good. This is also going to be -2, 0, which would look like this, which would make that not good. This would be like something like this, okay? So I know that that's going to be, because it goes above, this is going to actually be a line, okay? Okay, now this has a range of all real numbers, because if I label this, okay, all right, smallest x is -infinity, biggest x, that's all reals. Both those are infinity, so that's all reals. So those are the only two. Okay, using words describe what happened. Okay, here's how you can write this. Subtract, let's say 2 from x. All right, multiply 3 by y. Okay, pretty simple. Using words contrast. Okay, this one adds 4 to x. This subtracts 4 from y. I would also take the example of this anchor point would be 4, 0. This anchor point would be 0, -4. Either way would be acceptable. Okay? All right, so that's it for chapter 1. Go through that review and you should be fine. And the domain and range of this graph. Okay, so this point is -1, -2, -3, 1, 2, and 1, 2, and 3. So -3, -3. This point right here is 1, 2, 3, 4. So that's 1, 4 up. This point is 4 over 2 up. All right, for domain, what I want to do is I want to look at the smallest x and then the biggest x. Okay, so my smallest x is -3. Okay, which I'm going to put a closed circle there. My biggest x is 4, which I'll put an open there because on no line or anything because I have that. For the range, I'm looking for the small y and the big y. Okay, in my case, the small y is -3. The big y is 4. Okay, all right. I'm going to put a line under both because they're both closed circles at where they are. Okay. State the domain at intervals where it's increasing and decreasing for the graph. Okay. For an arrow here, that's a left arrow. My left arrow that's going to be -infinity. Okay, because that's the left side. All right. This is going to be -infinity because it's going down. Okay. Also staying with that right arrow is going to be positive infinity and it's going up. So right and up. So it's very similar to everything else there. All right. These other points, that's -2, 2. Okay, this is 0, 1, 2, 3, 4, 5. That's 0, 5. You also want to look at this point right here, which is 2, 1. Okay? All right, so you want to look at all that stuff. All right? So for the domain, I'm looking at the smallest x. The smallest x value is going to be -infinity. Okay? Those always get an open line. All right, what's the biggest x? That's going to be positive infinity. Okay? So that's what the domain is. The range. What's the biggest, the smallest y? Smallest y is -infinity. Okay? Biggest y is positive infinity. Okay? So it goes all through that. Now, where is it increasing and decreasing? Okay. Increase, decrease. All right? From -infinity to -2, it's increasing. All right? So from -infinity to -2, all right? Notice I have that. That's going to be increasing. All right? From 0 to 2, that's going to be decreasing. Okay? From 2 to infinity, that's going to be another increase. Okay? That's going to be another increase. All right? I think that's it. Okay? And if you go over that, make sure you know the key thing is a couple things you're going to have to be able to do well with this. Number one is in the calculator. You got to be able to, when you're in this area, know which one to find. All right, when you're testing, when you're calculating in the regression, you got to look at what the words say. That tells you, or the selections. The other thing you should be able to do, all right, when you do this, you should be able to copy, hit execute, go back into your graph, hit select, and be able to draw it. Okay, you got to be able to do that. All right, G-solve and this will calculate whatever you want. The other thing that's going to be key for you on this test is understanding this stuff right here. Which one of these is this? Follow this pattern for every single problem and then answer your questions. All right, you'll be fine.